Alright, so let's deal with a more complicated example, which is the linear systems of differential equations. So let's consider the system of two differential equations, x double prime equals to negative 3x plus y, and y double prime equals to negative 2x, just 2x, minus 2y, plus 40 times sine 3t. To make things easier, let's assume all the initial values are 0. Well, because all the initial values are 0, it makes the Laplace transforms easier, because if we plug this into the top, that means all these terms went away. Alright, so the first step to solve this linear system is to take Laplace transform of the whole thing. So we get Laplace transform of x double prime, which is s squared times x of s, equals to negative 3 times capital X plus capital Y, and s squared times capital Y equals to 2 capital X minus 2 capital Y plus 40 times the Laplace transform of sine 3t. If you look up, this is equal to 3 over s squared plus 9 according to the table. Okay, and moving terms around, we get s squared plus 3 times x minus y equal to 0, and 2 times x plus s squared plus 2 times y equals to 120 over s squared plus 9. So this is the linear system of two equations. We can use Cramer's rule to solve for x and y. Let's just solve for x first. So x is equal to the quotient of two determinants. The denominator is the determinants of the coefficients. Negative 1, this should be negative. Negative 2, s squared plus 2. And the numerator is almost the same, except the first column is replaced by the constant term. So 0, and then 120 over s squared plus 9. And if we calculate this, the numerator is easier because there's a 0. So this is equal to 120 over s squared plus 9. And the denominator is s to the 4th plus 5s squared plus 6 minus 2. This is equal to s to the 4th plus 5s squared plus 4, which factors into s squared plus 1, s squared plus 4. So x is equal to 120 over s squared plus 1, s squared plus 4, s squared plus 9. Okay, so we're going to move to the next page. So remember, we get x is equal to 120 over s squared plus 1, s squared plus 4, s squared plus 9. So we're going to, again, use the partial fraction method, similar to the previous video. And so this is equal to 3 fractions added together. The denominators are x squared plus 1, s squared plus 4, s squared plus 9. And as we have done in the previous example, this function is even, so there's no odd terms, so we can assume that numerators are just a, b, and c. Okay, now multiply by the denominator on both sides. So we get 120 equals to a times s squared plus 4 times s squared plus 9 plus b times s squared plus 1, s squared plus 9 plus c times s squared plus 1, s squared plus 4. And here we're going to use the similar trick that we learned with partial fractions. So if we plug in s squared equals to negative 1, then b and c terms go away. We get 120 is equals to a times 3 times 8. So a is equal to 5. Same thing. If we plug in s squared equal to negative 4, then a and c go away. So we get 120 equals to b times 3 times negative 3. Negative 3 times 5. So b is equal to negative 8. And then same thing for c. So we plug in s squared equal to negative 9. We get 120 is equal to c times negative 8 times negative 5. So c is equal to 3. So therefore, our capital X is equal to 5 over s squared plus 1 minus 8 over s squared plus 4 plus 3 over s squared plus 9. And this is equal to 5 over, let's take the constants out. So this is equal to 5 times 1 over s squared plus 1 minus 4 times 2 over s squared plus 4 plus 3 over s squared plus 9. And this is capital X, which is the Laplace transform. So we have to take the inverse Laplace transform. So we get little x of t is the inverse Laplace transform of these three functions added together. And we know the inverse Laplace transform of this is sine t, and the inverse Laplace transform of this is sine 2t, and the inverse Laplace transform of this is sine 3t. So the solution is x equals to 5 sine t minus 4 sine 2t plus sine 3t. That's for x. And we have to do all these procedures for y. We're not going to run this in again. So same process for y. We get y of t is equal to 10 times sine t plus 4 times sine 2t minus 6 times sine 3t. Alright, so this is how you solve a system of differential equations using Laplace transforms.